The last set of problems in the 5.2 problem set 25 to 28 are actually pretty straightforward because they give you the heats of formation values. So not a lot of trickery here by any stretch. They want to know what would be the change in enthalpy in kilojoules per mole for the reaction. Fe3O4 plus 2C yields 3Fe plus 2CO, and there should be a 2 here. And so then they give you the values for Fe3O4 is negative 1118. The carbon is in elements, so it's going to be 0, as is the iron. And then the CO2, I do have to take 2 times the negative 394. And then I take products minus reactants. So this is actually going to be plus an 1118 here. To yield my total enthalpy change is going to be positive something, I believe here, positive 330 kilojoules per mole. Remember, I'd be like to write mole minus 1 instead of putting the little slash. Number 26, very similar. NO2 has an enthalpy or heat of formation of 33.2, an enthalpy of formation, if you will. I have to take that times 2, and then N2O4 is a positive 9.2. So product minus reactant is going to be 9.2 minus the 66.4, and that's going to give me a delta H for number 26 equal to negative 57.2 kilojoules per mole. 27 and 28 following along in the exact same manner. I've got 2 H2O2 at minus 188 each. I've got 2 H2O at minus 286 each, and the O, oxygen is going to be 0, so 2 times the negative 286, and then it's going to be minus 2 times negative 188, and the sum of that for number 27 is negative 196 kilojoules per mole. And finally, number 28, MgO has a heat of formation of negative 602, and I have to double that. Carbon 0, magnesium 0. CO2, once again, is negative 394, and there's just one of them. So I'm going to take the 394 minus a minus 1204, or in other words, plus 1204, and I get a delta H of positive 810 kilojoules per mole.